Hi guys, it's Mrs. Kruger here. Today we're going to be talking about 7.2. I'm going to start on page 11. So the page 11 is labeled with a 7.2 warm-up. So we're going to just review some concepts and then go into 7.2 day 1. Okay, so if we look, we have a circle here. The center is going to be B. They're going to ask us some questions about this. The first question they're going to ask is, it says, what type of triangle is triangle ABC? And explain how you determine your answer. So the cool thing is we're going to go back to some geometry stuff that we talked about first semester. This is an isosceles triangle, and the reason why, so if they wanted to know what type of triangle that is, okay, triangle ABC is going to be an isosceles triangle. And the reason why is because back when we were doing proofs, one of our reasons were all radii are congruent. So BA and BC are each a radius of the circle, so they are going to be congruent, therefore that's going to make it isosceles. So that was the first thing they wanted to know. Now it says, how are angle BAC, here's angle BAC, and BCA, so this guy here and this guy here, how are they related to each other? Well, they're going to be congruent, because if you remember back in geometry as well, when we were doing proofs, there was a theorem that said if you have congruent sides, then your congruent base angles are going to be congruent. So since it's an isosceles triangle and you have congruent sides, then the base angles are going to be congruent. So this was the theorem that we learned back first semester. So number 3 says angle DBC, this guy here, angle DBC, this one's on the outside here, is going to be the exterior angle. How can you find the measure of angle DBC? Okay, so how can you find the measure of angle DBC without using the measure of angle ABC? So we know that if we had angle ABC, which is right here, these guys are a linear pair, so they're supplementary. So we would easily find that just by taking, if we know this angle, we could take 180 minus it to find that guy. So what they're saying is what happens if you don't have that angle. So there was another rule that we learned that said the exterior angle is equal to the sum of the remote interior angles. So that was another geometry rule that we learned, that this exterior angle is equal to the sum of the remote interior. So then they say give angle BAC, which is here, and angle BCA a specific measurement to use. So let's just make that number up here. Let's call these 42 degrees. Now we know they have to be the same, because we talked about that. They have to be the same. So if we wanted to find the measure of angle DBC, there's a couple different ways you can do that. You could finish the triangle. So if you did 3 angles of a triangle equal 180, you could find this angle, and then these guys are the linear pair or the supplement. But if we wanted to use the exterior angle theorem, the exterior angle is equal to the sum of the remote interior. So angle DBC, which that's my exterior angle, is equal to the sum of the remote interior angles. That would be 42 plus 42. So angle DBC would be 84 degrees. Now that's just an example. We just threw numbers in there, okay, to get that to work. So that was just a review of some geometry topics from last semester. So now let's see what they want us to do. They're saying if angle DBC is 80 degrees. So let me get rid of some of this stuff here. Okay, so if angle DBC is 80 degrees, what is the measure of BAC? Which is all the way over here. Now, honestly, I think the way you guys would go about doing that is if they gave you the exterior angle is going to be 80, I do think you'd find the linear pair or the supplement would be 100. Because these guys have to be supplementary. So then you know that there's going to be 3 angles of a triangle equal 180. So if this guy's 100, I have 80 between these two of them, which in a way you know that the exterior angle is equal to the sum of the remote interior. So if you just take 80 and divide it by 2, you will get the 40 degrees. That's a little bit of a review there. All right, so that was number 4. So if you go to number 5, let me erase what I have up here. They said if angle BAC is 30, what's the measure of DBC? So if I know that this angle is 30, I also know this angle is 30. So this is kind of like the question we just did. If I want to know the angle or the measure of angle DBC, which is my exterior angle, is equal to the sum of the remote interior. So my sum of my remote interior would just be 30 plus 30, which is going to be 60 degrees. So there's your warm-up before we get to some definitions today. Just reviewing some concepts that we learned first semester. All right, next, we're going to start page 12, which is 7.2, day 1. We're going to look at some definitions of some properties of circles. So I drew some pictures here out that go along with some of these vocab words. First word you need to know is an arc. I think you know what an arc is. An arc is any portion of the circle. So anything on the outside rim here of the circle is considered to be an arc. Now there's different types of arcs, as we're going to see. There's minor arcs, major arcs, and semicircles. So we're going to talk about how we're going to label those. So we know that the arc is going to be anywhere on the outside. So we have minor arcs, an arc that's going to be less than 180 degrees. So a full circle is 360 degrees. We know half of a circle would be 180. We're going to get to that when we get to the semicircle. So anything less than that is going to be a minor arc. So some minor arcs here on this picture is going to be arc AC. Now how you label a minor arc is you use 2 letters, it has to be 2 letters because it's less than 180, and you put this little arc symbol above. Another one would be, like over here, would be DC, arc DC with the arc label. Now you could switch the letters, so arc AC is the same thing as arc CA, and arc DC would be the same arc as CD. So the order of the letters can be switched, just so you know. Next we have a major arc. Think about a big arc. That's the one that's going to be bigger than 180 degrees. Now it's very important that we use 3 letters so you know the direction we're going. So let's just say I start at A and I swing all the way around and I stop at C. That's a major arc because we went past the 180 and we went towards C. So how we would label that would be arc A, D, C. Now major arcs that are bigger than 180 have to use 3 letters. And the reason why you have to use 3 letters is so you know what direction that you're going in. That's your major arc. So next we have a semicircle. We know that's a half of a circle, which is 180 degrees. We do name a semicircle with 3 letters. Okay, the reason why is because we need to know which way on the circle we're going to swing. Because if I took this picture and I just said arc AD, I don't know if you're going to swing this way for arc AD or this way for arc AD. So the only way we could do, now B is going to be my center, so it cuts out the diameter of a circle, okay, a semicircle does. So we're going to go this way, because the way my picture has it, this is the only way that I can swing that. Use 3 letters. So in this picture, for my semicircle, I'm going to call it A, C, D. You have to use 3 letters, and it tells you to go from A to C to D. So that's half of a circle. It cuts out the diameter, so you know it's 180. All right, next we have a central angle. I drew a central angle here. How you know that you have a central angle is that the vertex here has to come from the smack dab center of the circle. So a central angle will come from the center of the circle. The vertex is smack dab center. We're going to be talking a lot about central angles, or different type of angles there. So to name this guy here, we would just call it angle HIJ, or we could call it angle JIH, either one. Just know that the vertex of the angle is smack dab center of the circle. Next definition is going to be an intercepted arc. I just drew a random picture. It could be, all different types of pictures, but the definition is the portion of the circle that lies between 2 lines, rays, or line segments that intersect the circle. So usually you're going to have some kind of intersection. So these guys here, the arc that's going to be intersected is going to be EG. So what they're saying is if I look at this angle, my intercepted arc is going to be the arc that gets cut out by that angle. So from this picture that we have here, arc EG would be my intercepted arc. Because if I traced over the angle that I have, the arc that's cut out by that angle is called the intercepted arc. So that's the first round of some definitions. Let's look at some of the ones on the bottom. All right, next we have inscribed angle. An inscribed angle is formed when 2 secant lines, or a secant and a tangent, intersect at a point on the circle. Now, we're going to talk about what a secant and a tangent is in a second. But what's important about this type of angle is if you trace over this angle, okay, the vertex of this angle is sitting on the circle. If I back up here, remember my central angle where my vertex angle was smack dab center? This vertex is sitting on the circle. That's going to be very important when we start our circle angle formulas, because they're going to ask you, where is the vertex? Where is the vertex? Is it smack dab center? Is it sitting on the circle? Those are things that you're going to need to know. So this is called an inscribed angle. So anytime the vertex is sitting on the circle, it's going to be called an inscribed angle. So on is the important thing to remember there. Then the next 2 things is you will have to know, have an idea of what secant and tangent means. A secant line is a line that intersects the circle at exactly 2 points. So I just drew one here. See how you have a line going through and it intersects the circle at 2 points? That's just called a secant. So it has to go through the circle and intersect at 2 points, compared to what's the difference between a secant versus a tangent. Okay, tangent lines, and you're going to learn about tangent lines definitely next year, so you're going to need to know what these guys are. A tangent line intersects a circle at exactly 1 point. So a tangent line kind of runs on the outside of the circle, and it only touches it in exactly 1 point right here. So just with all those definitions that we learned before, you're going to have to know what's the difference between a secant line and what's the difference between a tangent line. And those are 2 pictures that go with those definitions. Okay, good luck.